IFREE ESI Friday lecture. Thank IFREE for their generous donation of this lecture series. We have with us today Sean Crockett, who's assistant professor in the Department of Economics and Finance at Baruch College. He is an alumnus of our graduate student workshop and was a pre-doc visitor with us when we were at Mason. And he's working with a former student of ours as well, Ryan O'Brien. He's going to talk today about trading away the endowment effect.
Thanks for having me out, guys. This is joint work with our mutual friend Ryan. The title changes every 5 minutes. Well, maybe it was 10 minutes ago that it changed last. So this will be the title going to go through a lot of iterations before we finally settle on one. So the endowment effect is a behavioral regularity that began to be discussed in the 1980s. This is sort of a seminal list of papers where the conventional experiment was you bring subjects into a lab, you bring subjects into a lab, you show them a coffee mug, and then you elicit willingness to pay for the coffee mug. With another group of subjects, you actually give them the coffee mug and then elicit a willingness to accept. And the elicited willingness to accept are way higher than the willingness to pay, and people have interpreted this as an endowment effect. So your evaluation of a good is conditional on whether you own the good or not. And so it's not independent of your point of preference. A nice sort of another way of showing the endowment effect, which is nice given our theoretical and experimental design, was by John List in 2004, where he brought people into a room and showed them a chocolate bar and a mug. And then with one group of subjects, he would give them the chocolate bar and ask them, would you be willing to trade this chocolate bar for a mug? And 81% of the subjects kept their chocolate bar. They wouldn't trade it for the mug. And in the other treatment, where he would actually give them the mug and ask them if you'd like to trade it for the chocolate bar, 77% of them kept the mug. So this also has been interpreted as having a very strong endowment effect. So you like mugs more if you're given a mug, you like chocolate bars more if you're given a chocolate bar. So Tversky and Kahneman in 91 JPE paper develop a theory which will explain, or amongst other behavioral regularities that have been identified, will explain the endowment effect. Okay, so it's a theory of behavior that will recover an endowment effect by making these behavioral assumptions. The assumptions are loss aversion, diminishing sensitivity and gains, and diminishing sensitivity and losses. These might look familiar to you from their prospect theory paper. So these, you can think of this as deterministic good space or attribute space analog to what they did in prospect theory, okay, which was on lotteries overwhelm. Okay. Monroe and Sugden in a 2003 paper showed that only loss aversion and diminishing sensitivity and gains were necessary to explain all of the behavioral regularities that have been identified in the experimental literature, so that diminishing sensitivity and losses wasn't useful in explaining any of the irregularities. Again, this is only in the economic space, the good space, not in the financial setting. And also, in fact, that the diminishing sensitivity and losses actually works against a couple of irregularities. So they assume an axiom that's going to imply loss aversion, DSG, and increasing sensitivity and losses. In this paper, we're going to be agnostic on the issue of sensitivity and losses, so we're going to make the assumption of loss aversion and DSG, as in Tversky and Kahneman, and we're going to say we're going to make the assumption of non-diminishing sensitivity and losses. So they can be we can have no sensitivity and losses at all, or we can have increasing sensitivity and losses, but we don't want there to be diminishing sensitivity and losses. And this seems to be a fair assumption to make ex ante, because DSL doesn't explain any of the data and actually seems to work against some of the data. So this is the framework within which we're going to operate. Okay. So the neoclassical structure on preferences that we're going to impose. So we're only going to be looking at two good worlds. There's some intuition for the results that we have that extend to larger worlds, but there's a lot that goes, a lot of ambiguity as well, so we're going to completely stay away from that. We're going to assume preference orderings, which are conditional on a reference point, and a reference point is just a bundle in the commodity space. we're going to make these first four assumptions, which are just standard neoclassical assumptions that are geared towards preferences that are conditional on a reference point. We're going to say given reference bundle or commodity bundle R, whatever that is. We'll talk about that more in a minute. The preference ordering on R is complete, transitive, strictly monotonic, and continuous. Very conventional neoclassical setup. So for a given R, indifference curves look like we normally expect them to look like. Assumption A5 is also that these orderings are continuous for changes in R. So for small changes in R, the difference curves don't change much. Okay? Just intuitively. Again, these are stated formally in the paper, but intuitively this is what we have. All right, and then, so those are just neoclassical assumptions that are put into our framework so that we can apply a lot of standard theory on these things. Now for the reference dependence assumption. Yeah, you guys won't be able to see this board if I draw it, so let's try to, it's more intuitive if I can. Can you? All right.
We can turn.
It's more intuitive if I put them out this way. So if you have, here's good 1, here's good 2, you have endowment bundle X, you have endowment bundle Y, or consumption bundle X, consumption bundle Y. All right, X and Y are on the same indifference curve relative to some bundle R, okay? So again, all those first 5 assumptions we're saying is that conditional on your reference point, everything's nice and clean as under standard preferences. What the axioms say is that, okay, now consider a move from reference bundle R to another reference bundle, call it S. Suppose R and S are the same on good 2 dimensions, so they only change on good 1, okay? And S has more of good 1 than R does, okay? So we're changing in reference point from R to S, so all we're doing is increasing the amount of good 1 in our reference bundle, okay? What that does is the move from R to S increases the relative preference for good 1, so that the new consumption, the new indifference curve through bundle X will look like that. Okay, so now X is strictly preferred to Y when we move from R to S. Okay, loss aversion is restricting R and S to be between the amount of good 1 in bundle Y and the amount of good 1 in bundle X. So this is the domain on which loss aversion plays. So for any R and S that meet those criteria in that range, this is loss aversion. Okay, and then diminishing sensitivity and gains. We have R and S. So if our R's and S lie in this range, diminishing sensitivity and gain says is that in moving from R to S, we're going to shift indifference curves this way as well. And then this region is our non-diminishing sensitivity and losses, so that if we have some R and S over here, and again, it doesn't matter what the amount of good 2 is, these R's and S's could be here and here and here, it doesn't matter. Then in this region we have non-diminishing sensitivity and losses, which says if you move from R to S, you're going to increase the relative preference for good 1. So your indifference curve through bundle X is going to rotate in this direction. Okay? Under the original assumption of Tversky and Kahneman, which is increasing sensitivity and losses, in this domain, if you move from R to S, you actually rotate preferences in the other direction, and that you can see that coupled, you can have move from here out to here, those two things work in opposite directions, and then it can create discontinuity, actually imposes discontinuity in preferences and all kinds of nastiness. So it actually is a very mathematically inconvenient assumption, as well as doesn't seem to match up with any of the data. So again, we're not doing away with their assumption entirely, we're just remaining agnostic on it. So we throughout the paper, we just rely on either constant sensitivity and losses or increasing sensitivity and losses. And again, Monroe and Sugden, their assumption just says that in moving from any R to any S where S has more of good 1 than R does, preferences rotate in this direction. See.
Are these hypotheses about preferences, or is there any kind of, it sounds like the like some of this literature gives indirect evidence that favors it, but is there any direct evidence that would be, say, analogous to revealed preference kinds of arguments or things like that?
It's a great question. It's a great question. So there are many behavioral regularities. The most commonly demonstrated one is the endowment effect, but there's other ones that the assumption in particular of DSG and loss aversion are consistent with those assumptions, and I'll show why in a minute. So you know, if you have preferences that change in this particular way, they will imply the most of the behavioral regularities that we observe. Recently, Masatlioglu at Michigan has shown direct support for loss aversion and diminishing sensitivity. Loss aversion and DSG. He did not test DSL or ISL again because it's a lot harder to impose the losses that would be in the lab on that dimension. So he didn't test that one, but he tested DSG and loss aversion directly with a revealed preference study and found strong support for both of those assumptions. So these assumptions were developed by Tversky and Kahneman. In one way they're ad hoc-ish because they're basically borrowed from prospect theory and say, okay, let's see if we can generalize those things to non-stochastic spaces with multiple attributes, and let's see if we can find a natural analog of those theories, incorporate them into econ. And look, they explain a lot of data too, so that's sort of where they come from. But they do, at least the first two, DSG and loss aversion, have been tested directly and seem to get a lot of support from the study of Masatlioglu. So again, the sensitivity and losses in the economics domain is still very much an open question empirically. The other two seem to have at this point in time, have pretty strong support. Yeah.
So why is it that people behave that way when you move from R to S?
Yeah. Is that a backhanded way of asking what constitutes R and S? Or I mean that goes together with the same question, I suppose. Like what are the reference points anyway, and why?
His question was this is what appears how people behave. The question is why do people appear to behave that way?
Yeah. I don't know, and I haven't seen anyone attempt to answer why it is that people would behave in this way. So I mean, the history of where these evolve from is that they're evolving from just an analog to prospect theory. They explain a lot of the data, and now they've been tested directly. But I haven't seen anyone that sort of has tried to get deeply into the idea of like why are preferences changing this particular way. And it's only very, very recently been a focal point of study to actually look at what constitutes a reference point. So I've been throwing around these terms like reference point R, reference point S. If you move from R to S, these things change. What is your reference point? That question itself has only been addressed formally in the past year, at least in published research. So I mean, this stuff it was a hot area in the 80s, and then sort of developing theories of what would explain these behavioral anomalies were developed in the 90s, and then things kind of laid low, and then Kosygin and Rabin had a paper in 06, and Segui had a paper in 06, and both of those were theoretical papers, but they actually pushed people to run a lot more experiments than they had before. So I think that now's kind of a time where people are exploring questions like that. But we're not going to be able to answer that question. I haven't seen anyone else try to answer that question yet either.
I mean, so this is just treating your endowment like the endowment is the reference point here. That's presumably what changes your...
That's going to be our...
In some sense, prospect theory is the same way. It's just as if you're treating your current wealth as your endowment, as an endowment in some sense.
That's going to be our position going forward, and that's going to be our maintained assumption in the theoretical section of the paper. So we're going to assume your current endowment, whatever that is your current reference point. We're also going to consider trade amongst agents with preferences like this, and as they're trading, they're not consuming anything, so the Edgeworth box stays fixed, right, until the exchange process is completed. But at each point along the way, whatever commodity bundle they've acquired, that becomes their new reference point. That's called the current endowment.
If endowments are sort of reference point, then you'd think, for instance, that if you live in different regimes regarding property rights or something like this, different notions of what belongs to you, that you might get different types of effects like this.
I would
because I mean, it really is, you're sort of treating that it's yours,
yes,
which is a property right, basically.
Yeah.
And so it seems like you can toy with property rights regimes even within an experiment and get sort of unusual notions of what's your endowment.
I would expect.
Like suppose, for instance, your endowment, you don't know for certain whether you have your endowment or something like that. Would that affect your behavior?
Right. What constitutes an endowment has been the subject of 2 theory papers by Kosicki and Rabin, and then 3 experiments that are either forthcoming or out in 2011 that have actually kind of got into the nitty-gritty of what is an endowment. And consensus has become that it has something strongly to do with expectation. So what you expect to be consuming shortly is, so even if if what your realization is looks different than what your expectation is, the reference point actually seems to be more in line with what you expected to be consumed than what you actually end up getting to consume. So expectations appear to be a much more important part of what constitutes an endowment than we would have expected 2 years ago. When the theory was written. So this becomes so this is something that it's pretty much like cutting edge experimental research of what constitutes a reference point. But I think, considering environments in which like even property rights aren't clear, there's different regimes, and sort of how does that impact what one considers a reference point would be. I mean, that seems to me to be a very interesting and topical research question, but I don't think that's been studied directly either. Yeah.
With the candy bar, coffee mug, I would guess that there's some kind of file drawer effect too on this research. What else is out there in terms of
what is
stuff?
A file drawer?
Stuff that's not public.
People just publish the findings that
are surprised.
You've never heard of a file drawer? Yeah.
Okay.
Right. So negative. That's where your non-findings are.
Right.
So, I'm just curious about the stuff that people use in experiments, and it seemed like that was, a noteworthy difference in effects of 80%, 60%. What else are you aware of?
Actually, so all the earlier research, to my knowledge, was done with coffee mugs or calendars, school calendars, and elicited willingness to pay and accepts in dollars. So it's one good, 1 unit of one good for dollars. The list experiment is the first to which I'm aware we're actually considering preferences over 2 goods, but again, both are limited to 1 unit of each good. And the Maslioglu paper, which isn't published yet, that shows strong support for loss aversion in DSG. He's using divisible chocolate. So he's using like small packets of chocolate, which is something we're going to be using in this experiment. But chocolate in mugs would probably constitute 95% of the studies. So chocolate's, And it's one of those things where, since everyone else was doing chocolate in mugs, then you kind of, I'm going to chocolate mug. We're going to use lottery tickets as one of our other goods, so instant win, scratch-off lottery tickets. In hindsight, part of me wishes we actually would have done 2 types of lottery tickets, one low variance, one high variance, and had them trade those and use people's intrinsic heterogeneous preferences over types of lotteries to get the types of, I think that would have been a nice design ex post, but ex ante, you have no idea. So, but we're going to use lottery tickets and chocolate bars in our actual experiment. So that's add one more thing that now people are using as far as goods go is scratch off lottery tickets. But there's not much else out there in terms of goods. There's lots and lots of papers. They all use mugs and chocolate bars for the most part. All right. So that's the theory. Again, we're just going to maintain the current endowment hypothesis for the theory. I do believe our theory could be extended to expected endowments. The problem is that we're going to be using a very abstract trading mechanism, basically any trading mechanism that has very general properties will give us our results. If you're going to deal with expectations, I think you have to have a theory that was dealt much more closely with particular mechanisms to form expectations of what in this particular mechanism do I expect to see happen. So I don't think you can get theory as general as ours is to what we think would happen if we switch the current endowment hypothesis to an expected endowment hypothesis. But I think the intuition for an expected endowment hypothesis would still give us the same types of results that we're going to get in this paper. So that's just a conjecture. I think that we get something similar. Okay. All right, so we have three main propositions in the paper. The first one is trivial, but we call it a proposition because we're just going to sort of test these three. The first one is, I'm just going to discuss it intuitively unless someone's interested in the particular details. If an individual, so suppose we have individuals who start with nothing and they get a gift of good 1. If you give someone good 1, their indifference curves are going to rotate clockwise. So that's the endowment effect. So if for an individual who's starting at a bundle 0, 0, and he has some neoclassical preference map given bundle 0, 0, if you give him some amount of good 1 as an endowment, so you give him a mug or a chocolate, whatever happens to be on the x-axis, all of his indifference curves are going to rotate clockwise. If you give him instead good 2, all of his indifference curves are going to rotate counterclockwise. Okay. So that's proposition 1. We're going to test that.
These axioms are sufficient conditions for an endowment effect.
Yes.
But that means that there may be other things that cause
absolutely
endowment effect. So
people have talked, like for example, one common one is kinked indifference curves.
So how can you go and then say if you have an endowment effect, you're going to get this movement if there could be other things that are causing the endowment effect and not this?
I'm sorry, can you say it?
You're equating the endowment effect with this particular movement.
Oh, I'm sorry. So yeah, so I'm using shorthand relative to what I'm calling proposition 1 in the paper. So proposition 1 is going to imply an endowment effect, but they're not.
Basically, the implication of proposition.
An implication of proposition 1 is the endowment effect. So yeah, so it's correct in the paper. This is shorthand.
Okay.
All right. So let me show you graphically. I mean, we already kind of showed it over there. Monroe and Sugden give a really nice functional form for a particular class of reference-dependent preferences. They have a reference-dependent CES utility function. So the reference point just plugs in really nicely to the CES function that has the same properties that CES functions has that we all know and love. And it gives us a really, really nice and clean example of all of our propositions going forward. So I'm going to be coming back to this example many times during the theoretical part of this talk. So imagine you're agent 1 and you have reference bundle 0, 0, and we're eliciting a preference for you for 1 unit of good 1 and 0 units of good y. And suppose we can look into your brain and see what your indifference curve at that bundle looks like. And again, I'm actually assuming that this good is divisible, obviously. So half a mug probably wouldn't do you very much good. And maybe you should think about the goods like chocolate, right? Or lottery tickets. So what happens if you give someone, say, a mug, if that's good 1, when you give them the mug, his indifference curve at that particular point and all other indifference curves are going to rotate that way. I'm sorry, no. I'm sorry, the other way around, I'm sorry. The dashed curve is his original indifference curve. If you give him the mug, his indifference curve rotates that way. Notice that in the example that I've drawn, he would have been indifferent between a mug and a chocolate bar when you didn't give him anything. So if he walked into the lab and you had given him the question, would you prefer that I give you a mug or would you prefer that I give you a chocolate bar? He would have said, I don't care. I like them both equally the same, right? If you actually give him the mug, he's not going to trade it for the chocolate bar. Now the chocolate bar is dominated by the mug, correct? So now imagine that we have another person in the experiment and we give this subject a chocolate bar, right? Well, his original indifference curve, and he's otherwise identical to this first person. So his indifference curve looks like that. If we actually give him the chocolate bar, his indifference curve is going to rotate this way, right? It's going to become deeper in that direction. And so if we put these two in the Edgeworth box, right? So agent 1 is at this lower left coordinate axis. Agent 2 is at the upper right coordinate axis. Their initial Pareto set weakly included switching endowments. Okay, so this is where we start off agent 1 with a mug and no chocolate bar, agent 2 with a chocolate bar and no mug. If they were not reference dependent, they would have been indifferent to staying there or swapping endowments, right? It's weakly included in that Pareto set. But once we actually give them their endowments, we get rotation in this direction of agent 1, rotation in that direction of agent 2, and so the Pareto set shrinks dramatically. The original contract set was this curve up here. Now it's this curve down here. So anticipating what the next results are going to be is that the endowment effect has a strong and debilitating effect on trading prospects. So this is where Kahneman has an AER 2003 paper where he suggests that the endowment effect is going to induce stickiness in markets, and people aren't going to be willing to trade as much because of this endowment effect. All right. So this is the endowment effect. Obviously, in all the experiments that have been run until the very recent ones, goods weren't divisible, right? So there's going to be no trade at all. Right? But it's important in this particular example to see that even though we have an endowment effect, with this particular set of preferences for these two agents, they would still be willing to trade a little bit of mug for a little bit of chocolate bar, right? So if the goods are divisible, there's still some gains to be had in the Edgeworth box. Okay, and that's going to be important. Are we clear so far on the endowment effect?
Well, I mean, it depends on how far those things are. You get it so it collapses.
Absolutely. So we can get it so that all trade can be pointing into the negative, or so they both have to short in order to. But it's always the case that so if the initial preferences had ex ante been a Pareto optimum, and then you gave them a new endowment, then they'd only want to short stuff, right? So you can get all kinds of stuff like that, but you're still not going to see any trade in the lab. So you're going to see weekly less trade in the lab because of the endowment.
You're obviously assuming convex preferences.
Yeah, I haven't assumed it yet to get the rotation of indifference curves. When I talk about trade and contract, I will definitely assume. So the preferences that I've drawn are convex.
So does that hold up in the lab for these types of trades?
We don't test. Well, okay. So Kareev and Fishman have a paper where they show an algorithm for computing what they call a CCEI score, which is the degree of deviance from rationality, which includes monotonicity, convexity, other kind of standard preferences. We haven't.
Convexity isn't really rationality, though. I don't think, is it?
Not nearly so rational as monotonicity. It's often bunched in that. You can quibble on whether it's rational or not. It's certainly more rational than concave preferences for goods.
I'm just saying, over the range that you're talking about these experiments,
yes.
You're not talking about large changes in a person's aggregate endowment. Do I want to carry around a chocolate bar and a mug, or or a half a chocolate bar and half, not half a mug, but half whatever,
right.
Rather than, there are things like that it's not clear to me that you have a strong tendency towards convexity of preferences in those environments.
It's a good question, one I don't have a good answer to. We certainly have many subjects who exhibit, who have...
You have to sort it out from these effects here also if you're not doing something specific, without an endowment effect in it. But
can you say it again?
When you have the endowment effect, arising here, it's not clear it's not clear to me how you sort out convexity or non-convexity of preferences with things that might arise.
Yeah, so we need convexity to get our trade results, but to identify the type of reference-dependent rotation away from endowments that I don't need convexity for that result, and that's going to be the main testable implication of the experiment. So I'm not going to rely on convexity for the main results of the experiment, but we need it for the theory for sure. Okay.
So all the revealed preference tests look for weakly convex preferences, and to the extent that those have shown that choices are consistent with revealed preference, they're showing that preferences are that they're consistent with convexity or weak convexity.
Yes.
And like Jim Cox's tests of these have been they've pretty strongly confirmed consistency with the existence of revealed preference. I think he's got like a 98 paper in the Economic Journal probably the most comprehensive tests that he's done.
Okay, I did that. That's a look at that. I'm not doing nothing right. Thanks. All right. Our second proposition, I'm just going to state it informally, is that under trade. So now we want to think about two people who now have been given an endowment. Okay, so you have someone with some amount of good 1 and someone else with some amount of good 2. And now I want to ask, and I'm going to make suppose we have a continuous space of goods to be able to trade, and suppose we have a situation where trade exists in the positive quadrant of the Edgeworth box. So we're not going to, we have these no short sales. So trade can actually happen in the positive. So we're going to think of trade of good 1 for good 2. So you're not, think of, there's no free lunch. You can't get both good 1 and good 2. Obviously, if we have multilateral trades and trade, we can have that. We're going to eliminate that. So we're not going to allow for that in our setup. So every trade has to be, you have to give up something to get something. All right. So under trade, which means getting one good and giving up the other good in our setup, if you trade good 1 for good 2. Okay, so in this graph, you're moving in that direction. Right? If you trade good 1 for good 2, your indifference curves, by the axioms as stated and under the current endowment hypothesis, are going to rotate counterclockwise. Right? And if you trade good 2 for good 1, they're going to rotate clockwise. Right? So if we go back to this graph, sure, the endowment effect rotated things to make the lens tight. But if these guys actually trade in this direction, this lens is going to get less tight. They have to rotate back in the other direction. Okay? That's proposition 2. So B was Pareto optimal relative to A. So going back to this graph, B is on this contract curve. Right? But if these two guys trade to B, which ex ante was Pareto optimal, so we have this tangency of the two solid indifference curves, if B becomes the current reference point, we get a fanning out of the two indifference curves, which basically the idea is that if guy 1 starts with all apples, guy 2 starts with all oranges, it means guy 1 really has a strong preference for apples, guy 2 gets a really strong preference for oranges. But maybe you'd be willing to trade one of your apples for one of those oranges. Well, in trading that one apple and getting that one orange, it increases your relative preference for orange compared to what it used to be, and it does the opposite for the guy who started with all oranges, and it pushes subsequent trades in that direction. All right. So that's our proposition 2. So trades move in the opposite direction of the endowment effect. So the rotation of preferences rotate in the opposite direction relative to that initial endowment effect. Yeah.
Does that process continue until you get back to a Pareto optimum relative to the original preference?
That's propositions 3 and 4 and 5. But yeah, that's where we're going. And that's what actually, to kind of go the whole way to what you're suggesting, under symmetric reference dependent CES preferences, the Pareto set relative to the 0, 0 reference point is identical to the set of all final states of exchange between these two guys. So even though the contract set under the endowment effect was pulled really close to the endowment, if you let these guys trade, they'll actually get out to the Pareto set. They'll get to a point where they're not willing to trade anymore, and that point will be in the set of original Pareto optima from when both person had a 0, 0 reference point. So the endowment effect is completely washed away with symmetric reference dependency ES preferences. But that'll be our next proposition. Yeah.
Do you have any intuitions about if you had an experiment where people came in and they did these trades like week after week and it wasn't just in one session, if you would still be finding?
So in the 2004 list paper, he also looks at experienced versus inexperienced subjects and finds a much smaller endowment effect for experienced subjects. In a sense, conjecture being that you can learn to not rotate your preferences so much with experience in the environment. I think that what we're going to find in our experiment is certainly consistent with this finding as well, although we don't have inexperienced and experienced subjects, but we do get that this sort of like the endowment effect goes away under exposure to the possibility of trading in a market. Whether that's experience or whether that's expectation form, I mean, we're not going to be able to say what's causing it, but we're definitely getting a movement away from. So we do find the preferences being drawn towards the endowment initially, and then they're getting drawn away from the endowment under the prospect of trade. But yeah, that's something. So List has found something consistent with, I think, what your idea was, is that experience seems to take away the endowment effect, and I think all of those things are related. Experience, exposure to market trading conditions, things. I think there's some connection there, but it hasn't been. No one's put it all together yet.
So, I mean, this is a timeless story that you're telling. The reference point suggests instantaneously in this process.
Yes.
So that you instantaneously basically adopt the new endowment. There's nothing that's ever consumed or anything like that.
Exactly. You only consume what's gains from trade has been exhausted in our model.
So is there evidence on the persistence of endowment effects? Do these things change, to use Coasian terms, in the twinkling of an eye, or not?
So our preferences, which we're going to elicit twice from subjects, which also makes ours novel relative to other designs which only do a static elicitation, they change dramatically. So, and dramatically means like in the space of 1 hour and 2 elicitations, we get dramatically different preferences for a lot of subjects. Mm-hmm. So
they don't eat the chocolate?
They don't eat the chocolate until after the experiment's over.
Oh, okay.
They do get one piece of chocolate to eat at the beginning, so they know what they're trading for, what they're getting. But yeah, so it does seem that these things change quickly. All right, so then our propositions 3 through 5, we have one for a two-age and two-good economy, and then generalizations to larger economies. We would first have to put some more structure on these economies. As Dan suggested, we're definitely assuming strict convexity of preferences for a given reference point. We're also going to assume that all trade is weakly Pareto improving, like conditional on a given reference point. You're always going into the lens somewhere. And we're also going to assume a limit non-trivial improvement condition, which is basically if the measure of Pareto improving trades is positive, that basically you don't dink around the edge of the lens forever. You got to go into the lens at some point, and it's not a strong condition. So these are the 3 conditions that we have. Under these conditions, we prove an acyclicity lemma that Monroe and Sugden, because they're assuming more than general goods, like given that we're only looking at 2 goods, they have to assume an acyclicity lemma. We're actually able to prove it under the other assumptions, which is basically there's always going to exist a neighborhood about an allocation to which exchange can never return. So they have to assume this is an important assumption. So you don't, under their, otherwise. You imagine, as with prospect theory, people who have prospect theory preferences under stochastic wealth distributions can be subject to a money pump. The same concern is here. Monroe and Sugden have to assume that you can't return to a neighborhood of the current endowment under trade. We actually show that under the maintained assumptions with 2 goods, you can't do that. So this is a small theoretical contribution of the paper, at least the 2 good economies. And then we're able to use this lemma to prove propositions 3 for 5, which intuitively, again, I'd like to get into the experiment, so I don't want to go into these in a lot of detail. There's that resting points of exchange, and what this comes from Monroe and Sugden. They call them reflexive Pareto optima. So an allocation that's Pareto optimal when the allocation is itself the reference point, right? So resting points of exchange lie further from the initial endowment than allocation in the initial endowment's Pareto set. So there's a separation of the reference-dependent contract set from the endowment by the endowment's Pareto set. In 2 goods, that's an easy proposition, a relatively easy proposition to show. It took a long time to prove it for more generally, and it's a weaker condition, but it's pretty similar. And again, it's not as interesting as the experiment, I don't think. But I think just from the graphs that I've been showing, it's intuitive that something along these lines should hold under the propositions that we've shown already, right? So here's what we have with our parametric CES example. This dark curve represents the original Pareto set when both people considered 0, 0 their reference bundle. Okay, so we weren't in the Edgeworth box. They were both at their own origin. That was the Pareto set for both of them. It also turns out it's what we can call the reference independent Pareto set under these particular CES preferences. So someone whose preferences do not adjust with a reference point, so they're CES but have the same exponential parameter as a reference dependent guy, those are also the Pareto sets for all reference dependent agents with that exponential parameter on their CES utility function. So we can consider this the reference independent Pareto set and the Pareto set for both agents that are reference dependent but who have 0, 0 as their current reference bundle. When they get this corner endowment, this becomes a Pareto set relative to the initial endowment. So it pulled the Pareto set all the way down to here. But if they trade to bundle B, the Pareto set relative to bundle B is this dashed line. If they trade to that one and get to bundle C, then this becomes the Pareto set relative to bundle C, and you get this convergence result towards the initial Pareto set, the reference independent Pareto set. So you can see that under this parametric example, we can completely do away with the endowment effect, which is kind of a cool thing in example form, right? We have no examples where we can show the endowment effect. This is the only parametric example we have. So I can't tell you if we have no results on whether a momentum effect always can outweigh the endowment effect, or sometimes it's less, or sometimes it's more. This is the only example I have. We know that the momentum effect always puts the reflexive Pareto set on this side of the initial contract curve relative to the endowment. That extends to higher dimensions with some caveats, but it's a weaker form. It's on averages and things of that nature. But again, not important.
Do these agents have identical preferences?
In this example, they have identical preferences.
Where you have a straight line Pareto set if you've got identical preferences.
Yeah, these guys have a straight line.
One thing you could possibly check is asymmetry.
I haven't checked it.
Just since it works in CES with symmetric preferences, potentially it would work with asymmetric, and it might extend it a little bit.
Yeah, actually, absolutely. I haven't checked it. I hadn't even thought to check it. That's a good idea. All right, so now we get to our experimental design. So we're going to, and this is all new. So the theory part has been in development for ages. This stuff has all been within the past couple of months. So we have an individual decision-making experiment. Subjects are recruited for an hour and 15 minutes. They're there for an hour. We're going to elicit preferences over lottery tickets and chocolates. All right, so we're going to have $2 New York Instant Win lottery tickets as one of our goods. And we're going to have chocolate from La Maison du Chocolat. They're Tobago chocolates. They retail from 80 cents to $1.25 a piece. They're individually wrapped with a nice little stamp on it. And that price range is depending on how many you order. So if you only get 15 at a time, they're 80 cents. If you order them 40 at a time, they're $1.25.
Other way around.
Oh, sorry. Everyone's looking at me like I clearly stated it wrong. Thank you.
Sit down.
I did 15 and 15.
So, yeah, at the beginning of the experiment, each subject has at his or her desk one ticket and one chocolate that they can look at, they can play around with. They can't scratch the ticket, they got to give that back to me. They do get to eat the chocolate to start. All right. And if they don't eat the chocolate, I collect it, but no one's ever not eaten the chocolate. Okay, and then we're going to give them corner endowments. We're going to, so they're either going to get 10 tickets and no chocolates, or 20 chocolates and no tickets. And then we're going to elicit preferences over this 10 by 20 grid, and then we're going to have some reallocation of initial endowments. I'll explain how that happens, and then I'm going to elicit preferences again. All right. And the preference elicitation is going to be incentive compatible, at least in some range of how we elicit them. Okay.
How did you recruit them if they weren't with you for any
Yeah, this is a problem. So my payment rates here in terms of what it's costing me is double what a normal experiment costs me, and yet every time I send out a recruitment email, they say, Professor, when are you going to run experiments with cash again? And they don't want to come. Yeah, so I'm giving them on average like 30, 35 bucks of stuff a piece in an hour, and they're and it's hard to get them to come.
It's not fungible.
It's exactly, which is part of it. I didn't want it to be perfectly fungible, and also they also have a really, really strong preference for the lottery tickets over the chocolates, which is problematic in terms of like some of the data actually is less usable than it could be because about 20% of the subjects have lexicographic preferences over lottery tickets. So that's problematic, but I'll get to that. Yeah.
Do you either tell them the expected value of the tickets or probe what they think it is?
I don't do either one. I've calculated it. Yeah, it's like $1.20 or something like that. But I didn't talk to them about it.
Is this where your idea of the low variance and high variance tickets came from? That you want to have those as the two commodities?
Yeah, it is. So I mean, the fact that one thing I could do to get rid of or potentially get rid of the number of lexicographic preferences I had. So initially what my concern was, I didn't want if I thought that these subjects had the idea that the chocolate endowment was worth about the same as the tickets, or every 2 chocolates was worth the same as tickets, that I'd elicit perfect substitutes. The preferences, and that I'd have problems. Like in the theory part, I need that convexity to get these nice lenses and get straight. So I was worried about substitutability. So I didn't tell them what the chocolate retailed at, and so chocolate tended to be way undervalued relative to market. If I had told them what the chocolate retailed at, it would probably have increased the preference for chocolate. In the same way that Nisi has the experiment on wine, when the wine's priced higher, people like it more, all that kind of stuff, right? So ex post, I would have done at least that. It's also, I think that on high variance, low variance lottery tickets, that I still could have gotten the convexity across the two. Like people still would have liked bundles of the two instead of extreme outcomes. But that people wouldn't have been lexicographic on one or the other. So ex post, I think 2 types of lotteries might have been nice goods to use, and just use people's own intrinsic preference for risk to get the kind of convexity that we get, in the theoretical model. But hindsight's always 20/20 with experiments. But we definitely have a lot of usable data that I think gives us really nice and compelling results. But you could always want more, right? So. But yeah, if I was to do a new experiment, or a follow-up experiment, I would probably do high and low variance lottery tickets. Boy, it doesn't show up real well, I'm sorry. So this is the preference elicitation procedure that I put subjects through. Over on the left-hand side, we have 2 columns of bundles, okay? Each one of these, it's this big, it looks like a domino. It has no dominoes. It's a little domino. On the left side is a number of lottery tickets, and on the right side is a number of chocolates. Okay, so each one of these dominoes represents a consumption bundle. Okay, over here is a matrix with slots from 1 to 57, and I'm asking subjects to rank bundles from favorite to least favorite. Okay, so they take a bundle. So here's a domino. It's got 5 tickets and 20 chocolates. Drag and drop this to where your relative rank of this bundle is relative to all the other ones on the grid. Once all the bundles are dragged over here, and you're allowed to rearrange as many times as you like, but once all 57 have been ranked, a submit button pops up, and then they do whatever rearrangement they like, and then they press submit, and that's a submission to me of what their preferences are. All right? I'll tell you why I give you the incentive compatibility mechanism in a second, but just imagine for now that they did it for the love of the game, and they're just going to take each of these dominoes and rank them according to their true preference. Okay, and importantly, 2 of these dominoes, one of them is 10-0, which is the ticket bundle, the corner endowment bundle, and another one is 0-20, which is the corner chocolate bundle. Okay, so they're going to drag and drop these in the order that they like it. What makes it incentive compatible is that after everyone has submitted their rankings, for each subject independently, I'm going to choose a bundle at random, and the probability that I select a given bundle is going to be decreasing in its rank. Okay, so the higher the number of the rank, meaning the less they like it, the less likely I'm going to select that bundle. Okay, and then if the bundle that I select from this probability distribution, if you've revealed to me that you like that bundle more than your initial endowment, I'll swap it for you. And if the bundle that I select you like less than your initial endowment, then you keep your initial endowment. So the selection mechanism is incentive compatible down to the rank of your initial endowment. So this is an incentive compatible mechanism to elicit preference or preference ordering over all these bundles down to the rank of whatever you've ranked your initial endowment. Okay.
So you said that many people seem to have lexicographic preferences. How many actually seem to have convex preferences?
I haven't tested convexity directly. It's something I should. It's actually the remaining. It's the thing that has to be done most on the analytical side is to get into. So we only have 3 subjects which have more than 7% violations of monotonicity. So most of our subjects don't violate monotonicity often at all. In fact, most don't violate monotonicity at all. But I haven't done tests of convexity. The CCI score does build in convexity. And so, I will be doing that kind of analysis, but I don't have the data for you now. Certainly some subjects, in looking at preferred 2 sets, have convex preferred 2 sets. At least, subject to an error here and error there, but they look pretty convex. I want to even say it seemed to me that outside of the lexicographic subjects, most subjects seem to have convex preferred 2 sets, but I can't say that for sure. That's just my gut feeling in looking at the data. Yeah.
How long do they spend on this task?
The first task, they take about 25 minutes, and the second one takes them about 20, and then there's 15 minutes of instruction.
They're not doing this for 25 minutes. That's not what you're telling me.
Do you think it should take them longer or less time?
Forever.
What's that?
It seems like forever. Yeah. 25 minutes, that's like,
I would say
I guess it's done in, let's call him Tim Shields to get it done in 30 seconds because, he's random. He's going to be sitting there for 20 minutes.
I think that the median subject finishes in the first one in about 12 or 13 minutes, and in the second round about 8 to 10 minutes. But there's always a couple that take longer, and I end it when they're done.
Oh, so you were the last person?
Yes. Yeah.
Okay.
All right. So here's the results, or at least the big picture. So far I've run 55 subjects through it, 34 with a corner ticket endowment, and 19 so far with a corner Chapman endowment. We do observe a strong endowment effect. We also do observe strong rotation of preferences in support of the theory. So rotation in the so if you start with a ticket endowment and I elicit these. I'm sorry, I didn't give you the full design. Sorry. So you start with your initial endowment. I do the randomization procedure, and then if the bundle that I pull is ranked better than your endowment, I give you that. Otherwise, you stay at your endowment, and then everyone runs through the procedure again. For those who traded, the new reference point, or the new bundle that kicks in, whether they trade or not, is their new endowment. Okay, so for example,
so the first time that you make the trade or make the exchange, right?
Yes.
Then you do it again.
Then I do it again. They start from the exact same position, and there's no memory, so I don't give them their old ranking. They have to re-rank everything.
So trade is with the experimenter.
Trade is with me directly. So yeah, for example, if you like 10 tickets and 16 chocolates more than 10 tickets and 0 chocolates, and that's the one, maybe you rank that number 3, and that's the one that I drew at random, then in the next period, whatever you rank that at, maybe you rank it 3 again, maybe you rank it 4, 2, whatever you rank that at, I'll do a random selection from the same probability distribution, and I'll only do a trade with you if I pick a bundle rank above this one. So I list your preference. So it's only incentive compatible in both periods down to the rank of what you currently own.
But there's a high probability that something that they very much like will be picked for the second time.
Yes, by the second time, yeah. Most people, by the end of the experiment, are walking out with something with almost all the tickets and almost all the chocolates. In fact, and there's a decent chance of getting something with almost all the tickets and almost all the chocolates possible in the first round, in which case I don't have very much data to use for that particular subject because there's not,
the second round, there's nothing. It's incentive compatible down to that first endowment. So if that was like 2, then you only got like 1.
2 data points, exactly. I have a very small preferred 2 set. And so, yes, for some subjects I just don't get a lot of that. So this is an expensive experiment to run both on a subject level and in a throwing away data level, but it's the best design I could come up with in a long period of time to actually test the momentum trading hypotheses.
But I don't see a 10-20.
It's up there. Oh, there's not a 10-20.
I see a 10-16. I think
I think there might be a 10-18. There's an 8-20. Yeah, there's not a, there's not, I'll show you the grid, and that's on, you'll see what the grid actually was, but in graphical form.
So they can't end up with 10-20.
They can't end up with 10-20. All right. Now, the results. We see a strong endowment effect. We see strong evidence of rotation in the direction that the theory suggests. Interestingly, and this is a big puzzle to us at first, is that we also find strong preference rotation in the same direction as own type traders. Own type meaning what you started with, what I endowed you with, for subjects who didn't trade at all. So even if you, so for example, suppose make this your corner endowment, and then let the dotted line be your initial indifference curve. Suppose we did the, so everything above here you ranked more, everything below here you ranked less, and suppose I drew, and my random draw was here, so you liked it less, so we didn't do a trade, your preferences still tended to rotate in that direction. Okay? We were very puzzled by this. We were disturbed by this. Like everything is going according to plan except for this. And then we find, so it contradicts the current endowment hypothesis. It's only then that we discovered this big and very, very recent literature, so our data is consistent with the expected endowment hypothesis, which has been explored in a lot of new papers. So basically, because we've given them corner endowments, everyone's expected endowment, unless you rank that in corner number 1, is going to be in that direction. So if you're a corner lottery ticket person, your expected endowment, you're in the second period, is going to be in that direction unless you rank the corner 1, which you're not going to rank the corner 1 if you have monotonic preferences. So everyone's expected endowment is going to go in the direction of trade that way for a ticket guy. In the chocolate guy, you start up here. Everyone's is going to be expected to go in that direction. So it turns out that the fact that we got rotation for people who didn't even trade strongly in the direction of what it would have been as if they had traded isn't a surprise relative to very new research that has just been published. So that made us feel much better. But I'll get to the specifics about it. Okay. So here's the CDF. Those of you that work with Ryan know that Ryan loves instant CDSs. But anyway, so this is the endowment effect. So the red curve is the rank for the bundle in which you're endowed, and the blue curve is the rank of the other corner bundle for which you weren't endowed. Okay, and you don't know, if I gave you 10 tickets and 0 chocolates, you don't know that anyone else. You don't have any reference point to 20-0. It's the same as any other bundle. You don't know there's other people who had that endowment. It's all private information. So we can see that the median subject ranked his own endowment at 20. The median subject ranked the other endowment, even though he didn't know it was another endowment. He ranked it at 50. So there's a big difference. This includes all data, both incentive compatible and non-incentive compatible data. This is just a big snapshot of pooling all the data to show the CDFs. But obviously, any statistical test we run on this data will show a strong and significant difference in distributions. We can do the differences separated by type. So if we look at the median rank of a lottery ticket subject, his median, the median rank of the corner lottery ticket down was 8. Remember, that's a lot. I mean, there's a lot of bundles out there, and 8 is really high for something with no chocolates at all. So that's highlighting the problem that we had. These guys really, really like tickets. the rank of that other corner endowment for subjects who were endowed with all chocolates was 28. So obviously that's a really big difference. So if you started with 0 tickets and 20 chocolates, you ranked 10 tickets and 0 chocolates 28. If you were given 10 tickets and 0 chocolates to start, you ranked that 8. Huge difference in the medians, sorry. The median doesn't show up at all for the other, and that's all incentive compatible. So obviously it has to be incentive compatible for all the ticket types, because that's, that bundle is incentive compatibly ranked. It's also incentive compatibly ranked for all but 3 of the 19 chocolate subjects, because they like that endowment so much. Okay? Only 3 of them like their own endowment more than 10-0. It's not nearly so clean in ranking the 0-20 bundle. So the median rank of the 0-20 bundle by someone who started with all tickets was 51. Only 6 of those 34 incentive compatibly ranked, and it's 48 by the chocolate endowed subject. So there's hardly any difference at all in the medians because there's a strong preference for tickets, but the distributions are far apart at the low quintile, right? So it's basically, the CDFs. I should have brought it up, but the CDFs are far apart down here, and then collapse by about 30 or 40%, and then there's hardly anyone that likes it beyond that point. So the CDFs are far apart. It's just they're far apart down at the low. The first quintile is 48 versus 30. So it looks much clean. It's a much cleaner test up here. And again, this is not, most of this data on the ticket side isn't incentive compatible anyway. So where we got to show the endowment effect really is on the first line. But anyway, there's clearly a strong one. Okay, at least in the stuff that we can show incentive compatibility in. So that's our first result. Our preference rotation result. Let me skip how we determine the statistic and go right to a picture. I think it makes it much more transparent. Imagine you're a lottery ticket subject, okay? And let's suppose you traded. Let's suppose that you traded to 10 chocolates and 5 tickets in the first period. Okay, and suppose the dotted line. Suppose the dark line was your indifference curve in the first period. Okay, suppose that was, I can't observe that. Suppose that's what you had. If that was the case, you would rank each one of these dots is a bundle that was available to be ranked. You would rank all these bundles greater than your endowment, and you would rank all these bundles greater than that allocation, and all these bundles less than your allocation. That allocation that you would have ended up with in the second period, right? If you had actually traded to that point, and your preferences rotated in the direction that our theory suggested would rotate, we would pick up some new bundles up there that are now preferred to 5, 10, right? And we would lose some bundles in here. Okay? So the statistic that we're gonna look at is if you were a corner ticket subject and traded somewhere, we're going to count the changes above and to the left of where you ended up, okay? The increases in the preferred to set as changes in favor of the theory, and decreases in this quadrant as observations against the theory. And then the reverse is true. So, and if your preferred to set shrank in this dimension, so if you lose some bundles, that's going to go against the theory. And if you add it down here, that's going to go against the theory as well. So we can think of counting the number of preference reversals at this particular incentive compatible bundle. We can count the number of preference reversals that favor the theory, the number against the theory, and then the number of elements in the preferred to set that stayed the same, and the number of elements in the less preferred to set that stayed the same. Okay, so we can do that count for that bundle, and then we can do that count at each and every incentive compatibly ranked bundle. So for each incentive compatibly ranked bundle, we can that was incentive compatibly ranked in both periods, or for each pair of bundles in which one was incentive compatibly ranked, I know the preference, or I know the relative preference between those two, and I can do these count exercises. All right, and obviously for the someone who is endowed with chocolate, they would, they would go in the other direction. All right, so I mean these 3 pages. Oops, sorry. These 3 pages of notation is just going through that counting exercise. But basically, I'm counting preference reversals in favor of the theory, and I'm counting preference reversals opposed to the theory, and the set of things which stays the same, which aren't even if preferences rotate. Obviously, a lot of the preferred 2 sets should stay the same. Right? All right. So here's what we find. These are conditional for subjects who have traded. Okay, so these are only subjects who actually traded in the first period, and it's only for incentive compatibly ranked bundles. So let's look at all the changes in preferred 2 sets. So there's only 2 types of changes: those for us and those against us. Let's imagine these mistakes are from a binomial distribution with equal probability, right? And look at the likelihood under that assumption that we would observe so many violations against us or for us. Okay? We find that 5 subjects are statistically at the 5% level against us, so we can reject at the 5% level of confidence that the errors were from a binomial distribution, that the errors were anti-momentum. And we have these 13 or 14 that we can eject that they were from the binomial distribution that are in favor of us. Okay, so we have of the subjects who had a statistically significant at the 5% level change in bias in their preference set, almost 3/4 of them changed in the direction that the theory suggests that they did. Okay, that they should, if they had been a ticket subject, that the preference rotations were in that direction, and if they had been a corner chocolate subject, the preference rotation would have been in that direction. All right. There's some other numbers displayed there. We also normalized that by the number of observations that stayed the same. So we divide through by that, because for a lot, so for someone who had maybe say 6 errors in our favor and 0 against us, and their preferred 2 set that stayed the same was only 6, that's someone who changed an awful lot in the area that I could actually observe them. Whereas someone who had 6 and 0, but they statically stayed, they were static in 100 observations, then they didn't change very much relative to, their changes were relatively little. So this is a way to normalize, because of basically the endogenous selection hurts us for people who got really highly ranked bundles in the first period. So we normalize by that. So we do observe, and then we have non-systematic people for whom we can't make statements one way or the other. A lot of them are lexicographic, and a lot of the other ones only have a couple of observations that stayed the same and reversals in either direction, so they're just not people that, so we have to come up with the appropriate way to filter those subjects. But at this point, I'm giving you everyone just to, you can see what's there. All right. If I add the subjects who did not trade, okay, we didn't add, so subjects who didn't trade, but let's do the same counting exercise by type, okay? We still have 5 in the anti-momentum column, so we didn't add anyone over here. And we added 10 over here. So the ones without stars are the ones who changed, okay? So the ones who didn't trade but rotated over anyway, and we added 10 more. So we actually have an awful lot of momentum traders, even those who didn't trade. So we have people whose preferences rotated in the momentum direction away from the endowment effect. That group gets really, really large once we include non-traders as well. And again, their behavior is consistent with the expected endowment hypothesis, but not consistent with the current endowment hypothesis. So it's indirect evidence in favor of the expected endowment hypothesis, which is also consistent with a lot of recent papers that we found. Yeah, and again, a lot of the people that we added to the middle column, again, are also lexicographic, or didn't really have much information one way or the other, so we have to filter them out somehow. And there's not any clear bias in terms of whether you were a ticket or a chocolate person. So this is a ticket, chocolate, ticket, chocolate, chocolate, ticket, chocolate. And over here as well, we have ticket, chocolate, ticket. So it doesn't seem, we're not getting a stronger effect from the people who are endowed with chocolates or endowed with tickets. They're both rotating in the way that we anticipated by the theory. Yeah, this is just going through words what I just explained now. And here's where we're finding. So Kasivi and Rabin, this is what gives us some cover for that last result. Say that they're assuming, it's theory paper, specifically a person's reference point is her probabilistic beliefs about the relevant consumption outcome held between the time she first focused on the decision determining the outcome and shortly before consumption occurs. So it's an expectation of where you're going to go before you pull the trigger, before you hit the submit button, that's forming your reference point and not what you actually end up at. And then this hypothesis of Kasivi and Rabin has been tested. This is a forthcoming QJE paper. This is a 2011 AER paper and a 2011 Econometrica, all of which are concerned with testing the current endowment hypothesis and relative to the expected endowment hypothesis, and all of them are siding heavily with the expected endowment hypothesis. All right. And the ones who did trade are still consistent with our expected endowment hypothesis, obviously, because all expected endowments, because we had corners, were all in the direction that the theory suggested it. All right. And then the last thing that we do is considered a hypothetical trading exercise, matching opposite type pairs. So you can imagine that I have preferred two sets for a ticket guy. I have a preferred two set for a chocolate guy. I can look at the intersection of those preferred two sets in an Edgeworth box and see if they would trade with each other and what happened to the Pareto set in period 1 to period 2. All right. So we do that exercise. So we're going to consider only the hypothetical Pareto set, right? It's a Pareto set. We're going to consider the Pareto set in the period 2 Edgeworth box because that is incentive compatible in both periods, because it's where you ended up at the end of the first period, that all the stuff that you liked more than that had to be incentive compatibly ranked in the first period, and all the stuff you liked more than that will have to be incentive compatibly ranked in this. So it's the maximal set of incentive compatibly ranked bundles. So compare basically the mean distance or the centroid of that Pareto set to each subject's initial endowment, and then look at the average of that. So and then we compare the period 1 to period 2. Our theory says that the distance from their initial endowment should get further in the second period. That's propositions 3 through 5. That as you trade, you should be moving away. Your Pareto set should be expanding, and your contract set should be moving away. So we run through that hypothetical exercise. What we find of our pairs is that we have 165 pairs that increase their distance, 42 that decrease their distance, and 439 that stay the same. So conditional on changing distance, 80% of changes were consistent with our theory. Of the non-changing pairs, almost all of them are on a preference elicitation boundary of the second period Edgeworth box, which means I can't observe what preferences are happening outside of the Edgeworth box. So imagine someone that in the second period has like three tickets and 20 chocolates, and they're at a singleton in the Pareto set. So the strict Pareto set in both periods is empty, so they're at a no trade equilibrium. It might be the case that his partner would both be willing to trade tickets for chocolates that would give him more chocolates, but I can't observe that because I don't have a preference elicitation grid that goes up to 21, 22, 23. So we surely can fairly filter people who have pairs that have singleton strict Pareto sets in both periods who are exactly on the preference elicitation boundary, because I can't see where the preferences are pointing into. So if we filter those subjects, there's only 50 non-changing pairs that are left. So almost all of these pairs that don't change, I can't see where they would change to. So it's just, it's an empty, I can't observe it, they're unobservables. And then of those 50 that don't change, 39 are only one grid point away from a boundary. So it's a similar situation where I can't, there's a wide range of angles of the margin rate substitutions where they could be apart, but I can't observe them. So basically, almost all the ones who aren't changing are stuff that we can reasonably filter away. Very few of the Pareto sets stay static that aren't on the boundary of the Edgeworth box where we can't observe where the trade would take place. So under that type of filter, remember 80% of the pairs that actually change distances or changing in favor in favor of the theory. Under this filter, 76% of the pairs increase their distances from period 1 to period 2, so that 24% don't increase their distance. Most of those are decreasing their distance, and 4% are not changing at all. All right, so that hypothetical trait exercise, the people that we can actually get fair observations on whether their Pareto set's changed or not, 80% of them were changing, okay, in favor of our theory. 75 to 80% were changing in favor of our theory, which seems to be a strong result. And these are just examples of what those look like. So here's the period 2 Edgeworth box for a pair who actually, both of them reallocated in the first period. So this is their new endowment point in the Edgeworth box. It was a no-trade equilibrium in the first period. This is from the perspective of chocolate subject as agent 1. So his endowment used to be here, and the other guy's endowment was on the other corner, the lottery ticket subject. After the first period, we get the first period is all blue. Sorry, the Pareto set in the first period was the blue region. The Pareto set in the second period shrank to here, so we get movement in the direction of the theory. So the Pareto set, here's the endowment. It opened up. There were gains from trade that they could have taken in the first period. By the second period, preferences rotated in this way and became close to tangent at this point, so it shrank the Pareto set away from the initial endowments. It pulled them away. Here's another example where they started close to a no-trade equilibrium, and then the Pareto set opened up away from the initial endowment. So it's just basically two sides of the same coin. Here's one where the Pareto set folds this way. Here we get the same rotation, but it's actually, they were close to tangent here, and in expanding out, they're actually opening up more trades in this direction. And then there's a no-trade equilibrium up there that in the second period gets really, really wide. Here's a pair who didn't trade at all, so this is the original Edgeworth box. Neither one of the types traded in the first period. Neither one of them would have had any Pareto improving trades in the first period with each other. In the second period, there's a lot of trades they would have made. So again, just these are CDFs of distances. This is with all the data. Thanks, Ryan. This with all the data, and this is separating the ones who are actually changing in distance. And I mean, we can see that there's obviously a big difference, although it's probably overkill in this case. And the conclusions are what I've already been talking about. We do observe an endowment effect. We do observe preference rotation. Of the people who rotate, they rotate strongly in our favor. Once we get through some appropriate filtering exercises on people who are lexicographic, obviously if you're lexicographic, you can't. We don't get anyone who starts lexicographic and then rotates. And then we don't have an indifference curve if you're lexicographic, right? So you can't, in the sense like you can't rotate a lexicographic preference. So we can surely filter those out, and we can probably filter out some of the ones who we just don't have any observable data on because they traded to something they really, really liked in the first period. But we do get a lot of the people who are rotating, they're rotating strongly in favor of our theory. And we also find indirect evidence of the expected endowment hypothesis over the current endowment hypothesis, which is consistent with a lot of recent papers. And I think that overall, what sort of the sort of big picture of our paper is that we're really calling into question the intuition from Kahneman that the endowment effect contributes to stickiness in markets and makes individuals less prone to exchange. It does initially, right? And if you limit individuals to trading on a discrete grid where they're, that endowment effect is strong enough that it rotates things in such a way that they're not able to trade into the lens because of discreteness, well then yeah, they're definitely going to be less likely to exchange. But if the space of goods is sufficiently continuous or sufficiently divisible in small numbers of units, we would expect them to trade a little bit. If we find the subjects or humans have convex preferences, we'd expect them to trade a little bit. The theory says if we take Tversky and Kahneman's axiom seriously in something like the current endowment hypothesis or expected endowment hypothesis, we would expect some exchange to take place. Their axiom suggests that as that exchange takes place, it's going to develop momentum that can completely cancel out the trading consequence of the endowment effect. So that's the final punchline. Maybe the endowment effect it appears to be a very important phenomenon in a static situation, But in a dynamic and more continuous one, it probably doesn't matter so much. Question? Yeah.
Sean, when we were still at Arizona, we developed a trading mechanism that was as efficient as double auction, except there was no trading. There were no binding trades until after people had exchanged bid-ask information of the uniform price double auction. Okay, and what we found is that it tended to be typically as good as double auction in terms of efficiency. And but none of the trades were binding until everyone traded. So what it was an implementation of the Edgeworth laws, of Edgeworth recontracting.
Yes.
See, and at one point there was a group of us in class. We applied that mechanism in endowment. Okay. We used mugs. U of A, Wildcat mug. And in your original thing there, you showed that 19 to 23% of the people traded. You had 77 and 81.
Oh yeah, right.
Okay, I like to think it in terms of how many people are getting it right, and rather than how many are getting it wrong.
Okay.
So you had 19 to 23. Well, we always did much better than that, and we got half to trade many times. So basically, now, in terms of what you said, what I see that we did was we had a way of trading so that they were approaching the reference independent.
Because in expectation, they were moving in that direction, so their preferences, you had
not only that, they were getting there in some groups.
Yeah. So the endowment effect was pulling preferences away from trade initially, but as they went through iterations of the hypothetical,
they're just trading once.
But they're making
different groups.
Right.
Okay, so the sample is different groups, and then they use this mechanism, and some of them hit half of the mugs of trade.
Yeah.
Okay. And there's a good reason why you would never expect more than half to trade. If people are hedging, and then the best are, if there's any error, if you write them in terms of supply, any error at all, it's going to be on the bottom side, not the top. But anyway, we're definitely getting pretty close to your.
Did you publish it?
Yeah, we published it. I don't remember where.
I gotta find it. All right.
Yeah, it's we did it a long time ago, so it's hard for me. Long time ago, that it's not as that I remember it in detail as if it were yesterday.
Yeah.
But we were getting a lot of.
Very cool.
See, the thing is, in that environment, the guy states the position at the beginning of the auction, but he can keep adjusting his position as he sees the other people state their positions.
Because incentives are always to do better, you see, in the process, and the information exchange process. And so we were looking at it, we were going at it from the point of view as how can we get better incentives in the trading mechanism to see if we get people half of them to trade.
Yeah.
And we did actually pretty well.
Very cool. Yeah, I definitely want to take a close look at that. That's really neat.
Any other questions?
This is just kind of a curiosity, but I was once at a conference and Richard Taylor was saying that he thought that the reason that there's excess trading in equities markets is because of preference reversals. And now we find that the reason that there's not enough trading is because of the endowment effect. And that's in some ways reveals a lot about the whole.
Now you see it, now you're going.
I mean, it's just like, whatever's a convenient explanation right now.
Right. No, exactly. So,
and there's, oddly enough, there's no attempt at a reconciliation of that. that inconsistency that I see.
Yeah. Yeah, it's definitely something. I mean, all of the sort of excess volume results, which conditional on an endowment and preferences at an endowment, you would get excess trading volumes if you have these types of reference-dependent preferences, but they all deal in lotteries over wealth, the ones that I've seen. And so, like, I don't like to draw the analog to a deterministic attribute good space so much, but I do think there's some parallel there that someone smarter than me can put it together and do something really nice with that connection, because there's a lot of those regularities in finance that might not really be puzzles if we have these kind of seesawing. You get an endowment, it pulls your preference. There might be something there that's worth looking into. All right.